Here we have to learn some more points regarding that glucose. These are cyclic ring structures. These structures obtained from these two structures. I will show those two structures now, how they obtained from those structures. See, this is alpha D glucose, this is beta D glucose. If you observe this structure carefully, this is look like cyclic structure. In that cyclic structure, 6 atoms are there in cyclic ring. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. That is nothing but a 6-membered ring. It looks like this. This is first carbon atom. This is second. This is third. This is fourth, fifth, sixth. This is first carbon atom. If OH is present on right side, that comes under lower side. This is first one. Second one, if OH is present on here also right side, again here OH comes lower side, H comes upper side. Here see OH present on left side, here H is present on right side. Then this H comes lower side, here upper side OH, because it is present in left side. Here OH is present on right side again, that comes lower side, H comes upper side. How many carbons finished? 1, 2, 3, 4. 1, 2, 3, 4. Now fifth carbon. This CH2OH, this contains, fifth carbon contains O, that is this oxygen. One side H, one side CH2OH. It should write like this: CH2OH, H. This is fifth carbon, this is sixth carbon. This is what cyclic structure for glucose. It looks like this structure. This is 6-membered ring. 1, 2, 3, 4, 5, 6. It looks like this. Its name is what? Pyran. So it is called glucopyranose. It is called glucopyranose. Nothing but alpha D glucopyranose. Alpha D plus glucopyranose. Similarly, it can also be written as like this. First write like this: 6-membered ring. This is first carbon, second, third, fourth, fifth, sixth. This first carbon is what? This OH present on left side, so it should be written in upper side. Then H can be written in lower side. Here OH is present on right side, it comes lower side, H comes upper side. Here also, here H present right side, it is down. Here OH in upper side. Here OH present on right side, that can be, and then that comes in lower side. This will be upper portion. This is fifth carbon. Here every time CH2OH. This is upper side, H lower side. 1, 2, 3, 4, 5, 6. If you observe these two structures, difference occurs at first carbon atom only. This is alpha. This is what? Beta D glucopyranose. Alpha beta D plus glucopyranose. See, if you observe these two structures, then you get clear idea. See, this is alpha D glucopyranose. H OH, H OH. Here H OH, H OH. Here OH upper side, H lower side, OH upper side, H lower side. H upper side, OH lower side, H upper side, OH lower side. This is also same. This beta D glucopyranose, this one. we can write like that. Next, one more point. The cyclic structures of glucose are called what? Hemiacetal. These are called hemiacetals. Hemiacetal means what? If a compound contains ether and alcohol present on same carbon, ether and alcohol present on same carbon, that is called hemiacetal. See, if you observe this carbon attached with OH, and this carbon also bonded with oxygen. Here this oxygen present between this carbon and this carbon. So this is ether group. That is why it is called hemiacetal. Next, one more point. That is what? These are enomers. Enomers means what? If configuration differs at functional group carbon. If configuration differs at functional group carbon. That means functional group should contain carbon. If configuration differs at that carbon, that is called enomers. Why it is called C1 enomers? See, this is the alpha D glucose, this is beta D glucose. If you observe these two structures, second, third, fourth, fifth, all are same, but first carbon is different, configuration different. Here OH comes left side, here OH comes right side. That is why these are C1 enomers. If suppose if this ring is not there, here CHO will be there, correct? That means that these structures obtained and these configurations differ at functional group carbon. That is why these are called enomers, C1 enomers. Next one, fructose. Naturally occurring fructose is levorotatory, hence it is called levulose. Glucose is dextrorotatory, that is why it is also called dextrose. It is levorotatory, naturally occurring fructose, that is why it is called levulose. Its molecular formula is C6H12O6 like glucose. The open chain structure of fructose is like this. That means here also we can write chemical properties. Based on chemical properties, we can write the structure of fructose. Here no need to write, no need to discuss about chemical properties of fructose. You just remember this is the structure for fructose. If you observe this structure, fructose contains ketone group. Here also OH group present on third side of left side of the third carbon atom. That is first chiral carbon. This is first chiral carbon. This is second. This is third. Only three chiral carbons are there. Next, here also 5 OH groups are present. 1, 2, 3, 4, 5. This open chain structure of fructose also does not obey some properties like glucose. So it is also having cyclic structures. Those cyclic structures are like this. That means these are obtained by addition of hydrogen of hydroxyl group of fifth carbon to second carbon, because here functional group is present at second carbon. Then we get two cyclic structures. Here these cyclic structures are alpha D fructose, beta D fructose. Why here alpha? Because this is the first chiral carbon. On first chiral carbon, OH is present on right side. Here OH is present on left side. That is why here this is beta, this is alpha. Next, why it is D? Because this is the highest chiral carbon. On highest chiral carbon, OH is present on right side. Here on a highest chiral carbon, here also OH is present on right side. So that is why it is D. Then why we should put minus? Because naturally occurring fructose is levorotatory. That is why we should put negative sign. It can also be written as like this, nothing but furan structure. That is why these are called alpha D fructopyranose and beta D fructopyranose, like glucopyranose structures. These two structures differ at second carbon. See, second carbon. Here second carbon containing OH group right side. Here OH group left side. That is why these are C2 enomers. These are also obtained due to this functional group. That means when OH group, when hydrogen is going to attack at this carbon, then only these structures obtained. That means these two structures are differ at functional group carbon. Functional group carbon. This is second carbon. Here also second carbon. That is why these are called C2 enomers. This is the structure for glucose. This is structure for mannose. This is structure for galactose. Here first compound. If you observe first compound and second compound, every configuration is same. The configuration means position of atoms, position of groups, except second carbon. See here, second carbon contains OH group right side. Here second carbon contains OH group left side, but the rest of the groups are same. That means here configuration differ at the second carbon. That is why these are called epimers, not anomers, because these carbons contains functional group, but that functional group is OH, not CHO or CO. That is why these are called epimers. If you observe these two structures, 1 and 3, those are different C4. See here OH group is present right side. Here OH group present left side. Rest of the groups are same. That is why these are called epimers. What is anomers? What is epimers? Anomers are what? Anomers are the isomers which differ due to functional group contain carbon. Then what about epimers? Epimers are the isomers which differs due to functional group do not contain carbon. This is all about carbohydrates. In next video we will discuss about amino acids. Thank you.